All right, the moment we've all been waiting for. I did have to make some adjustments here. As I suspected, this was kinked too much, and I tested it earlier and it just derailed right there. So I had to fix this section, and the other section that I was suspicious of, I was right there too, so I had to redo this section and pull it out a little more so that it was a more gradual curve at this point. But other than that, we should be good to go. So there's the engine. Let's give it a shot at the old transformer. I'm still gonna have to manually switch at this point, which is less than convenient, but here we go. And as always, I don't know why with this transformer, you turn it on, it goes backwards, turn it off, turn it back on, and it goes forward. And I'm gonna keep it nice and slow so that I have time to beat it around the corner here. There it comes. And I've got to switch this. There we go. Now I've got to get down to the other end and switch that. So what I'm going to do is just push in on here. I don't know what causes that little hesitancy every now and then on certain stretches of track, but generally speaking, I'm really happy with how it's running. It's really steady. And just so I don't have to switch it again, grab. There. Woohoo! The first successful full circuit run. I'm a happy camper. Now, let's get to work on the next part. Now, if I put in that gate I'm thinking of, like if I put it here and I have a gate going across and it pushes and swings the gate open, I can have a lever underneath that pushes this way and then pulls this out like that. The trouble is, once the gate is open, you know, if it opens like to here, once the train goes by, it'll snap back and the train won't have made it through all the way and it'll derail. So the only way to correct that is to have a gate that's long enough to allow it to make it all the way through. So I'd have to have a gate that's, you know, that long. So when it swings back, it's going to be way out here. But at least that way, when it opens, it'll hold it open all the way until it gets through, and then it'll snap back. So I think I'll go with that plan. Putting it on this side instead of this side makes a lot more sense, because when it pushes this way, it'll push the lever that way, because this thing has to go to the right. And I can attach it here and have it pull from underneath that way. So that is the plan right now, and require 3/8 inch hole being drilled here, and then I just have to make all the measurements to figure out how long the gate has to be and how long the shaft has to be that brings it all the way out to here and pushes through that way. So let me get started on that. Another gorgeous day out here. So I'm seeing how much I can get done. We're supposed to start getting some heavy rain, which we desperately need. And then it's going to get really cold. So for now, here's the gate that I designed and 3D printed. And it can pivot inside the collar. And the collar I'm going to fit right inside here. So let's see if I can squeeze that down a bit. So the idea, when that's in, is this thing will be out like this. Train will come through and push it, and after it's gone by, the spring will flip it back this way. So that hopefully will work. And how am I going to do this from underneath? Well, I've got this piece here. You notice the top of this has a square hole in it. This will come in from the bottom and peg into that square hole and glue in. And it has this little foot onto which is going to be a lever, which I have not yet concocted. And I don't think I'm going to make that lever out of plastic because I think it'll bend too much. I need something more like a piece of aluminum rod that can move that distance across here. And then over here, I've got this piece, which, let's see if I can focus. Da-da-da. I don't want to focus. There we are. This piece. And you can see it's got this little mouth here with a hole in it. And down here there's another hole. And this is going to slide right into here. If I can focus again. There we go. That'll slide right into here like that. And then I'll pin it in there, and then the other rod will come here, so when it goes, it'll pull. So that so far is what it's looking like. I've just got to figure out that rod part going across, and I also have to, I'm not sure if that's going to work, because if all this does is turn this way, yeah, it should pull. It should pull and pull that thing that way. We shall see. Depends on how much pressure is on this. So, but that's the beginning of the gate. Okay, this is installed nice and smooth. And then underneath, you can see, if I can get over here, you can see the piece that moves there. That's all locked in, that's glued in. It's not going anywhere as the geese go over. And then over here, this is what's going to pull. And that's really easy to push, so I don't think there's going to be, you're not going to need much pressure at all. It doesn't really need to move that far. Not as far as they're going. Anyway, it doesn't really need to move that far. And so I think when I position this, it won't have to be all the way over here. I can have it like only up to here, as long as it moves it just enough to open the gate to get the train through. Then, you know, this will be enough to move this. So probably just like that. And then when it moves it like that, it'll, well, I got to think this through, Jay, because you don't want it here because the train will come and crash into it. It's got to be at least over here. So I guess, hopefully if I push it here, and then when it turns, it'll pull this enough to clear the train and then snap back over to here. So as long as I can keep it out of harm's way of the train coming through this way, I should be okay. So, but that's for when I figure out what I'm going to use to get over across here and attach it to here, so that when it pulls, it'll just pull on this. So, part way there. You know, I should have really thought of this before I attempted to put this in. You know, I thought I was good, but watch this. It's never even going to make it to the gate because the body of the train collides with this thing. This would really need to be way back here in order to get out of harm's way, and a little bit this way, because I noticed when I ran the train around the corner, let's get it back over here, it slams into this as well, and it's going to come off the track. So I need to pull this out and then move this whole thing back this way more. Really, I mean, what it means is that I'm going to have to rebuild all this because this is all glued together now. So I'm going to have to rip it apart. I should have test fit it and then moved it back, but that's the way it goes. So this is okay, but this I'm going to have to move. So back to the old drawing board. Back on the workbench. Now, figured a few things out. First of all, I designed a plug for the hole that I created that is no longer needed. So I'll have this gray plug that I can stick in that hopefully will match up a little bit. I've redesigned the gate because it needs to be quite a bit longer. It used to be about this long. It's about 50 millimeters longer. And this will reach from the further back position that I need it to be at. And I think I have solved the lever problem of how I'm gonna make it work. The weak link in this is this thin stretch of plastic here. Most of it is gonna be inside this shaft. And I'm hoping it's gonna hold up, but I suspect this is gonna be the weak link in this. But what I've done to make the lever is I've simply used copper metal perf. It's very light and it's really sturdy. And what I need it to do is I need it to twist this way, so I need it to be stable in that direction. I don't care about up or down. So this will be very sturdy, and what I'm going to do is I'm going to get another metal perf piece and hinge it in here. So I'm going to put a bolt, but very lightly, so it can pivot. And then that will come over to this, and I'm redesigning this so that it has a bigger foot on the bottom. And that way the metal perf can come over here and attach to that metal foot. And so when this swings, the other piece of metal perf will push on this and pull it out. And I suspect, I'm hoping that will do it. And we will see. It's still raining pretty hard out, so I'm doing all this work inside, and once the rain has ended, then I will hop outside and see if any of this will function. All right, here is the design so far. This one had to be a lot longer. This one's going to be a bit shorter, but what I've worried about here, I mean, this will work. It's not a big deal. But what I'm worried about is that there's very little throw space on that gate because the switch itself only moves about 1/4 of an inch one way or another. And in order for the gate to move, it's got to move about 1 inch. So I'm not sure exactly how I'm going to deal with that, but I think what I'm going to do, here are the new arms here with the new foot on it, bigger foot. What I think I'm going to do is, instead of attaching these directly to the switch, I'm going to add a little spring in there, and with the little spring attached to it, it'll give it a little more play. So when the gate swings, it'll pull it open, and it'll still be able to open a little bit more, and it'll just stretch the spring a bit, and then when the train goes through, both springs will come back. So I think that's the way I'm going to have to do it, because I don't think there's going to be enough movement in that gate to let the train pass, since the switch just doesn't move that far. But we'll solve this eventually. Okay, well, I got everything in. I got the spring-loaded arm here attached. And notice how little that shaft actually does move. However, if I were to push this further, watch what happens down here. So this will move, and it just makes everything bounce. So that's not going to work. And if I hold this steady, you know, if I hold it up and pull this, what's happening is the plastic arm in here is just twisting. So there's not enough torque on this piece in order to really put pressure on this. So that's a failure. That's not going to work. Well, what's my next step then? I could send this out to the same company that made those ties for me, and I could have them make this entire unit in brass. And if they make it in brass, it'll never corrode, and it will have incredible strength. And then attaching the copper to it down here and over to here, this will still bend. So I'm gonna have to figure out a better way to do this. This just, you know, is too flimsy. If I hold this piece and pull it, it does pull. So in theory, it's possible, you know, but in its current state, it's not going to do anything. So it looks like this will not be running for Thanksgiving. Bummer. If it's not running for Thanksgiving, we'll just have to see how severe the winter is, because it will take several weeks to have this machined in brass. And even if that works, I'm pretty sure that will work, because I'm going to have enough torque on there to really pull that nice and solid. You know, another thing to do is to find a piece of steel that is 5 millimeters a side, which is what this is, and I could have simply a piece of steel go up into the plastic, but then I'm pretty sure what's going to happen is this will just crack. So it'd be better to have this whole, the collar and the shaft and the arm all made out of brass, and then I won't have to worry about it ever again. And that, I think, will give me enough torque on there. Then I'm going to have to figure out what I'm going to do with this down here, because obviously that's not working. It's nice and light, but it simply isn't tough enough. So I'm sure once this is brass, I can use heavier materials here in order to make sure it doesn't sag, and it'll have a good push on that. So once again, that phrase I love to use in these videos, back to the old drawing board.